homework 13 is the double and half angle identities. So I want to make sure I do a double and a half, and then we'll do one of the proving identities problems. So let's start with number 1. So this is a double angle, so sine of 2 theta. Always a good idea just to write down the actual formula so you have it in front of you and you know what you're trying to plug things into. So this is 2 times sine times cosine. So cosine is handed right to you. So what we do is we use cosine to find sine. So we could use the Pythagorean identity to do that. So sine squared plus cosine squared equals 1. So we've got sine squared plus cosine squared equals 1. So when I square this fraction, I get positive 9 over 25. And then subtract 1 minus 9 over 25. So it's like 25 minus 9. So you end up with this. And then you take the square root of both sides. So remember, square root technically includes a plus or minus, and the plus or minus is going to be dependent upon which quadrant you're in. So this is the same as 90 to 180. That would be in quadrant 2. When you're in quadrant 2, the value of sine is positive, because sine goes with y, and y is positive. So use a positive 4/5, and then you can just sub these values in. So the 2 is just a coefficient out front. Sine we just evaluated to be 4/5. Cosine was given to us as negative 3/5. Just simplify that up. So 2 times 4 is 8 times negative 3 over 1 times 5 times 5. And that would be your value. All right, let's do the first half angle formula. So they're number 4. Same thing, good thing to write down your formula so we know what we're dealing with. So big plus or minus, this is 1 plus cosine over 2. All right, so the formula needs cosine, but you were given sine, and you're given this right here, which is quadrant 1. So everything is positive in quadrant 1. So same formula that I just used up above. We have sine squared plus cosine squared equals 1. So when I square this, I get 49 over 625. When I subtract, you do 1 minus 49 over 625, which means 625 minus 49, which is 576 over 625. And then you take the square root of both sides. So remember I mentioned the quadrant was quadrant 1, so everything comes out positive in that quadrant. So take the square root. These might be values that you'd want to check in your calculator, but they are actually both perfect squares. So the square root of 576 is 24. Square root of 625 is 25. So that's the value of cosine. That value is going to get subbed into the formula. We'll talk about the plus or minus. So this actually, we don't really need to talk about it. If the original angle is in quadrant 1, when I cut those values in half, half of 0 to pi over 2 would be somewhere between 0 and pi over 4. So that is still in the first quadrant, so that is going to be positive. So I know that for sure. Under the square root, I have 1 plus, and then cosine, I have 24 over 25. And we'll work on simplifying that down to a nice reduced fraction. So I add these together. So remember, this is like 25 over 25. So I add 25 plus 24 over their common denominator, and divide that by 2. Okay, and then dividing by 2 is the same as multiplying by 1/2. So when I take this fraction and I multiply it by 1/2, what it does is it multiplies the 25 by 2. Okay, and this is a square root that I can simplify. So the square root of 49 is 7. The square root of 50, I can bring out 25. 25 times 2. So 5 comes out, a 2 is your leftover. And finally, multiply top and bottom by root 2. So root 2. And then when I multiply this by root 2, I end up with 5 times 2, which is 10. So that is your completely reduced irrational value there for number 4. And then let's flip over to the next page. We've got some different proofs of identities. Might as well start with the first one, number 7. So we start with the more complicated side. That's the right-hand side. So we are just going to leave cotangent the way it is and hope we can get the right-hand side to match. So we have a couple double angle formulas there. So sine of 2 theta, that is 2 times sine times cosine. And then in the denominator, of course, the 1 would be just fine the way it is. And then this, the cosine of 2 theta. Remember, as we were going through and looking at all of these identities, cosine has a bunch of different versions. So you've got options. This one, I'm going to talk you through why the one I'm going to choose is the best option. We have this one that's 1 minus 2 times sine squared. The reason we're going to choose that one is because when we do this, we have 1 minus, and then I'm going to do 1 minus 2 sine squared. What ends up happening there is the 1 minus 1 will cancel. So it might have taken some like playing around to figure out which one would have been the best one to use, but without using this one, the ones wouldn't have canceled, and then you'll see in the next step why it's important that the ones do cancel. So left-hand side, still cotangent. Right-hand side, I'm not touching the numerator. I'm going to work on simplifying the denominator. So 1 minus 1, gone. And then careful here, this is minus a negative. So that's positive 2 sine squared. So I just mentioned, you would see why I chose that one, why I needed the ones to cancel. And you'll see here, since these are just technically monomials, I can just start to reduce them. Remember, binomials, you have to be very careful, but with monomials, you can just start reducing. So those will cancel. And then I'm left with 1 copy of sine in the denominator. And then you take a look at what's left over, and cosine over sine, that's actually the very definition using one of our quotient rules. It just ends up being cotangent. So that is our proof.